done last year. George, you mentioned a little bit about it during the we have worked together with SC to open source the execution environment, and today you find the source code in GitHub between the repositories. It's one repository for the client application, it's a kernel driver, and so when we have that done, you will also need to create some kind of application that will have some kind of feature that you want to show and use. So how do you actually create such an application and how does that look like? And that is what this session is about. So what you need to do is you have the normal Linux binary running in the user space that calls initiate calls down to the world. And in the secure world, you have a application running. And with this solution is based on the global platform. So, in the platform, they have something called client gateway, and that is the way how you communicate with applications. It's basically 5 functions. The first thing you need to do is call the initialize context, which will basically just set up the context for the current session, because you're not going to be the kernel and give some private data to the environment. This is shown here. This is the difference. Describe everything. On the left side of the window that you have on the side, this is where you have the APIs integrated with the big data. So you have the beginning as well. There's a line down to the and back again. Then the next step, when you run that, is to open the section. And when you open the section, you see what the first parameter is the UUID. That is what is identifying the application that you're working on. This call will go all the way down to secure world, and it will find the first application that is going to run. It will be an application that is statically compiled into the core, and it could also be something that is dynamically loadable, and then you have an RPC mechanism that goes back to normal world, loads the trusted application, send it back to the secure world and check the signature of the trusted application.
You mean it's loaded on demand?
Load on demand. Oh yes.
Okay.
Yes, they will be loaded.
So in the context of this open session, call, the secure world will go back into the normal world to load the application. Once this returns, then that's all.
Yes. Good question. So this is exactly the answer to Art's question. This is how it's looking when you're calling it. So you have the same. It's always going down through the Linux kernel. All communication goes Linux kernel. You have an SMC call down to secure world, and then back and forth in between. So in this case, for the open session, when you enter the core, it looks and it will see is the trusted application already loading? Is it on static trusted application? It will load it. I mean, not if it's static, but if it's dynamic, it will load it, and then it will go back. And the loading is done using this RPC. You can see that it goes to something called tsupplicant, which is a daemon running in normal world serving for things like this. And what will happen when you call this open session is that you can see that's this TA open session entry point function that will be called in the trusted application. So in case you need to do some initial setup in the trusted application, that's where you can do that. So it's the first place where you actually call this approval. The next step is the actual invoke command, and this is using the function ID, and in this case it's the bolded in black TA hello world common int value, and that's just an integer saying
or identifying which function should be called in secure world. And you don't have to provide this UUID I mentioned in the beginning, since that's connected with the session already. And you have opened the session also, so you know which TA you are talking to. And it's basically the same call stack as for the open session. It's just go down to the secure world to the trust application, and it will, based on this function ID, you can have several. It will call the different functions and then you return back again. And when you're done, you have done whatever feature you are trying to, or service you're trying to run, you can call this invoke session several times, and then you're going to close it. So you have to call the close session and the finalize context. And then everything is done. You have unloaded the trusted applications. And this is actually the only steps involved in running and calling the trusted application. So invoke or initialize context, finalize context, like malloc and free, it needs to be called in pair. Same for open session and close session. You can show. And so, how are you actually creating this trusted application? What do you need to do? You need to clone a couple of Gits, the trusted OS itself that contains the development kit. You have the client API library that you need when you need to find the H files for the interface. You need to define this UUID, just random identifier. The functions that you want to implement, the unique integers I mentioned, that is something you need to set up in the file. And you need, of course, to have some kind of client that calls this. There are a couple of flags, two at least, that you need to set that point to these other two Gits that are needed to create the trusted application. And it could require more than one toolchain actually, depending on if it's 32 bits or 64 bits. And as a helper script, I'm using this one just to point it out. So the important thing is the two toolchains. Where are the dev kit? Where are the interfaces for the client API? So let's see if we can run some kind of demo. In the demo, one important thing is that all the trusted applications needs to be stored under /lib/tc, and that is the location where we are looking for the trusted applications when we're loading and running them. Next step is just normal things. You run FTP, mod probes, you get a driver, you run the supplicant so you can load applications, and then we just run the application. So, Jens, are you ready?
Yeah, sure. So I'm going to run this demo on the foundation fast model. I've already booted the Linux kernel, and I have my prompt here. So I start with loading the Linux, the driver for opt. And I start the supplicant. And now it's time to run the Hello World application. It will be really quick because it doesn't do very much. And now it's done. So what happened here is we called the trusted application with a value 42 as input and asked it to increment, and we got the result back 43. which was what we expected. As we can see down here, we have the log from Secure World, and the trusted application printed "Hello World" when the session was created, and afterwards, when we closed down the session, it said goodbye. Question.
So if you don't close or close a session or terminate whatever it's called, can you read secure RAM?
Sorry, could you take that again?
If you actually close session call that goes all the way from the normal world user land to kernel to secure world. But if you fail to do that, can it result in secure RAM leaking?
Yes, it could, but when the user space application is destroyed or does exit, the file descriptors are cleaned up, and as a result of that, the sessions are closed also.
Okay.
So that's how you create and run a trusted application. It's not that fancy when you're looking at demos from security stuff. It's normally just a log file. So, questions?
Hi, I was just wondering, if, a bit louder, are there any more complex examples in the upstream code base for doing secure applications, or, you know, is it?
Yeah, there are a lot of different trust applications already, and it's a little bit more complicated. So, but I mean, the concept is still the same. It's, you use it in the same way. It's just depending on how you are actually implementing your invoke function. That's the real magic, so to say. So, but this was more or less just to give a very easy overview for how it's looking and how are you actually creating these trusted applications. So, but you feel, I think there are 7, 8 different, at least, trusted applications for you.
In our test suite.
You know, yeah.
So how did you monitor the secure world debugs? At the bottom of the terminal, you were showing the secure world printouts.
That's just from UR print.
Right, but how do we, like, if I want to do that, how do I connect to it to see the printouts?
You enable debug prints when you're building it, and then it will show up basically.
Or when you just run the secure
Yeah.
world, it would. Okay.
Exactly.
Hey, I was just wondering, what is the complexity of the applications that can be actually run in the secure world? For example, if I'm looking at complex, DSP-like algorithms working, not really DSP, but math-heavy operations running in the secure world, is it possible?
Yes, it is. I mean, even in internal API pod has this arithmetical APIs. So if there are cryptographic algorithms that are not implemented, then you can actually use this arithmetical API. So, and it's supported by something called multi-precision MPA library also.
So is there some kind of documentation available that I can go through to? Is there some kind of documentation available in the open source that I can go through to see how exactly this is possible to be done? Because I've not, to be honest, I've not gone through the open source code right now. But yeah.
No, that's included.
Okay. Another question. So when I understand that the memory would be mapped between the host world and in the host OS and the secure OS, and the commands would typically flow from one world to the other world.
Yeah.
So what is the latency that we are looking at?
There is, I mean, the latency, In the past, on old platform, it was a problem when you were doing the context switching between normal and secure world, but now it's not. I mean, it's negligible now.
Oh, it's
I think it could be comparable with a syscall in Linux, maybe a bit cheaper.
all right. Thanks.
I have a question. The application between the secure world and the normal world is use the UUID to identify the unique. In my understanding, the UUID is not defined by the application. I want to know who manages the UUID.
Okay.
How to get it.
It's just to generate. In the source code, there's actually a link where on a page where you can generate it. It's just a standard UUID. So you just generate it. You can see it just like a hash or something, and you use that one. So it's a random number.
How to assure, for example, the SecureS have many applications, so the UUID of every application is unique, not the same. How to assure this? Maybe have some manager solution to ensure that UUID is not the same.
There is no such thing. I mean, this is a huge number basically. If you write it up, it will basically never collide with anything else.
But one way of ensuring that is, I mean, these TAs, they are signed. They have to be signed in order to be able to verify them when you load them. So when you sign a TA, it means that you say that this UUID is what I want, more or less. So that means that there shouldn't be any other TA that uses the same UUID, because then someone has signed something that shouldn't be signed.
Yeah, and I mean, it's up to the one that runs this, that does the signing also. So he's probably in control of the different trust applications that they are running.
Yes.
It shouldn't be any problem. I mean, it's just like everything else that uses hashes, for example. It could collide, but the likelihood is so small, so it's not a problem.
I'm very newbie to security. Actually, I do not know what exactly the security here means. So I would like to know, like, how we are sure that it is secured from what? Actually, I am a very newbie. I'm not sure if I am asking this, but what is exactly we are securing from, and how it is guaranteed that security has been already just seeing the it is secure. We do not know exactly if it is really been secure or not, and also the latency that the other guy is asking about. And also if it is really secure and if it is no latency, why can't we make all the applications secure using this by default, something like that? So I'm just wondering.
Okay, I think I got it. The main question, how can we know that this is secure? I mean, this is, by design, we use this hardware feature now called Trust Zone in ARM that has been available for a couple of years. And what is happening is there is an extra bit called NS bit that will be propagated into buses and different areas in the system. And that one manages who can access what. So as soon as you have switched to the secure side using the monitor, the NS bit isn't set, and that means that certain areas of the memory isn't accessible at all from a normal world point of view, and the same with peripherals. It could be dedicated, so certain peripherals can actually be used when you're in secure world, but some cannot. So you're actually trusting on some hardware mechanisms that makes this secure, so to say. And you had one more question.
Why can't we make all the applications secure by using this if there is no major latency?
Yeah, exactly. what we want to do also is to try to, I mean, if you just suddenly want to run everything in secure world, what will happen is you take everything you have in the Linux kernel and just move it down one layer, and then you probably have the same problem again. So we are trying to just identify the necessary and needed functionality that you want to use in secure world, and everything else should still be running in normal world as you always have been doing. So you can, use cases could be key storage, how do you handle decoding and decryption of video content, how do you handle secure payment. It's those kind of use cases that are interesting. But you don't want to move everything down into the secure world by default.
There's also another thing. The environment defined for a trusted application is a lot more, the environment is much smaller than the environment for a Linux application. So you can't do as much things. I mean, when you call a TA, it's expected to return quite soon after you have called it. It's not supposed to keep running forever. It should return back to normal world. But when you start a Linux user space application, it just continues to run, of course.
Thank you.
I think that's related to this question. We got one question on the Etherpad here. It's about how the OPT avoids impersonation attacks. In other words, ensure the verification of client identities before any operation on the behalf. I mean, it's the same kind of answer that we've been into. That trust applications are signed by the company that use this, and since they have control of the signing tools, signing keys and such, and also as signing was into the UUIDs, and it's verified using a standard signature, I mean, it should be safe. I mean,
But wasn't the question how the TA authenticates the client?
yeah, but it is how it authenticates. I mean, you have, if it matches the signature, then you know that.
Yeah, but how the TA can know that it's talking to the correct client, and that's a level of trust actually, because if it's a client in Linux user space, it has to trust the Linux kernel, and well, in secure world we don't trust normal world that much, but it has to. I mean, it doesn't really matter for the TA in that way, because if normal world is broken, then yeah, it's a problem.
Trust is factored out. The secure world doesn't contain, so
No.
take care to consider any call as untrusted.
Exactly.
But we have other clients also. We can have a client in secure world, and those clients we can trust entirely. I mean, the identity of that.
So the trust model is to not trust anything actually from normal world.
Sorry.
That means that no data that is actually confidential should go out of the team.
Yeah, exactly. Pascal said that no data that is confidential should get out of the T, and that's true. I mean, as soon as it leaves the secure world, someone can get this data, probably.
So, staying on this topic of trusting the applications in the host OS, the question is if there's one trusted application that's and linked to a trusted application in the host OS, how can we ensure that no other host application can fake the UUID or copy it from the host space and then try and connect to the trusted application that's sitting there?
I mean, if you should fake it, then you need to re-sign it and put it down on the file system again and run it again.
Sorry, I didn't get that.
If you should fake some call in some way, I mean, it's a service in secure world, then you need to actually modify the application, sign it again, put it on the file system again, and then the verification will fail.
So as I understand, the host application has this UUID that can be used to connect to the secure application.
Yeah.
Now, let's say some rogue application out there in the world has got hold of this UUID from in some way, right? Now, is it true that this rogue application now can connect to the trusted application using this UUID?
Okay, I mean, there is potential. If someone goes like man in the middle between actually going down to the secure world, then the trusted application or the call from normal world clients shouldn't really be trusted. So, I mean, if you don't have trust on the binaries running in normal world, if you don't have verification on those, then you can't really trust them. That falls back to the same question as we just had. You can't really trust normal world.
So it's always a one-to-one connection or a one-to-one link between one application in the host OS and one application in the trusted OS?
Not necessarily. It could actually be one to several. You can call several different trusted applications if you want to.
Okay, sorry. What I'm really trying to ask is it possible that there are, let's say, 5 normal world applications trying to access the one trusted OS application to, let's say, increment the number that we had in this application. But there's 1/6 application that I don't want to access, this trusted application.
So you're talking about normal world applications. That can be several normal world applications, of which one is a rogue one.
The 6th one, which I don't want that to call this trusted application to increment the number that was there.
Yeah, that would be responsibility of normal world.
Okay.
To ensure that I mean, when you do this, I don't remember if it's open session or it's create context, but there you can specify what login class, etc. that you have, and there you can build up some kind of level also of which application is which and so on, but that's a normal world responsibility.
All right. I think we'll have to go through that. Thanks.
We got one more question saying, do you recommend to open a session every time that the operation is required and close it after the TA return? Is that not much overhead? Well, you shouldn't open the session and close it every time. You should just open it once and do your invoke commands as many times as you need, and then you close the session. So it should just be one-to-one, basically.
Yeah, because open session can be quite a lot of overhead.
Yeah. So avoiding doing that and just calling invoke command. That's the answer.
I'm just wondering if there's any specific trusted applications that SWG are planning to implement, or is that for the Linaro members to do?
I mean, the closest we're looking at is relation with the home group. They are going to need something to decrypt video and decode, and that will probably relate to creating a trusted application for that one.
Oh, you'd be doing some consultancy with that, or some development? Or?
Pardon?
Sorry, would SWG be doing some consultancy on that stack or development?
Yeah, I mean, we're trying to help them with the low-level bits and pieces, but home group will do the actual work when it comes. Okay.
We have a question back there.
Okay, one more question, sure.
Is it possible to open a session in a kernel space?
Open a session in?
TA session.
Within the kernel?
Yeah, within the kernel.
Yeah, it's possible.
Okay.
Could you explain a little bit about how the trusted applications are signed and where the signature is stored, where the keys are stored, and how the signatures are verified?
Currently, we are just using a dummy header, basically, and just concatenate the created binary with that one. But in a real scenario, you should use your own private keys and open SSL or something, and then just create this header on the fly.
But that is, well, a vendor responsibility to define their own, well, signature schemes and so on. It's outside of our scope.
But we have a defined header now that looks in a certain way that is verified when we are calling this. But it's the thing that you find on the links we have here. The first link is just containing the dummy header that is concatenated with the binary. But for the details, if you need to create this yourself, I can give you the information.
So who is responsible for verifying the signature? Is that the trusted execution environment itself, or is that the
yes, it's
rich
the
OS?
so-called T-core in secure site.
And what's responsible for verifying the actual trusted execution environment image?
It's root of trust, chain of trust since the boot, actually.
Sorry, I can't hear.
It's the root of trust since you boot. It's already from the beginning, so you have the ROM code verifying next component and so on.
So on V8 it would be on trusted firmware.
Yeah.
And second question, is it very common to have dynamically loadable trusted applications, or is it also kind of an accepted method to have a monolithic trusted execution environment which contains the application directly?
In this case, Opti actually contains the both. You have the support for so-called static applications. You have to compile them directly into the binary in the core. And then you have the possibility to also load them dynamically.
Can you disable the dynamic loading feature and just have a monolithic trusted execution environment?
If you don't sign any dynamic TAs, you won't have any. But of course you could just disable the functionality to load them also. But if you have none, you have none to load.
Okay.
I mean, I think it's quite good actually to have the possibility to use trusted applications. Like in this case, if you're doing development, you can just, if you're up and running Android, you can just ADB push the binaries to this /libtc folder and then just run it again and again. If you would have been only using the static version, then you need to recompile everything and put everything in the system again. And it's, I mean, you can isolate a lot of things and just have a small development kit for creating the trusted applications also. Okay, and just as a final slide here, this is where you find the source code for the different pieces we have been talking about. First link is the actual Hello World application. Second link is where you find the 3 different Gits, the client, Linux kernel driver, and the operating system. It's quite connected with our trusted firmware nowadays when we are showing things and running. And currently the patch that is supposed to go into our trusted firmware is under review. So you'll find that one also. Very, very soon. Dan will take it. Okay, thank you very much.